Whoa, it's really starting to look like some decorations in my room for the holiday season. Whoa, we got a train going on over there. Coming around the corner. Got R2-D2 there with his hat. Look at all the lights in the back of my room. Whoa, it's lit up. Newbold, woo! Here comes the train. We got a Christmas village going on. Woo, Christmas village. Yeah. Yeah. Things are lit up. Whoa. Thanks for being here. Thanks for watching. Nice. Let me turn on the lights. There we go. Woo! So again, we got our Christmas entrance over there. Yeah. Hopefully you're all decorated up, ready to go. It's coming fast. It's coming fast. The holiday season is coming fast. So we are helping you now on 5.5. So 5.5, let's go. So don't forget how to add functions and plug in numbers, right? So for example, negative 3x plus 4 plus g of x, which is 7 minus x squared. And so we get negative x squared minus 3x. And then we have a 4 plus 7. And 4 plus 7 is 11. And now we're just going to plug in the negative 2. Negative 2, negative 2. You could have done them individually, actually. Could have done them individually, but that's fine. So then we got negative 2 squared. What's negative 2 squared? Try it on your own. Stop me. Pause me. Try it on your own. Try it on your own. So we get negative 2 squared. With the negative outside, that's a negative 4. And the negative times the negative is a positive 6 plus 11. So that's 17 minus 4. We got a 13. 13. Try number 2, where you're doing composition. Plug in G into H. Plug in G into H. This is just times. Just going to times them together. Yeah, it's good to remember all those things, right? Coming up for the ACTs. Number 5, how do we get a common denominator? Remember? Get a common denominator. Well, you got to factor the bottom. Now remember, you cannot eliminate the bottom because this is an addition problem. Addition is not solving. Solving is where you can eliminate the denominator. But this is addition. Combine the top over the bottom once. So we get an x minus 4 and an x plus 4. So then only one side. Only one side. Only one side to the top and bottom. Only one side to the top and bottom. And so it's just the x plus 4 that we need. To the top and bottom, x plus 4. So now we have a common denominator of x minus 4, x plus 4. And so we're going to distribute. So we get 5x squared plus 5 times 4 is 20x. Pause me. Try it on your own. Pause me. Try it on your own. All over x minus 4 times x plus 4. Don't forget to list the restrictions. Don't forget to list the restrictions. Yeah, so those are our 2 answers. Good. And then, yeah, don't forget to factor. Lots of factoring. Lots of factoring going on. You can even pull out an x on this one. Lots of factoring. Ooh, x squared minus 1. That's going to factor more. Whoa. So try it on your own. Try it on your own. Whoa, write it over 1. And remember, every whole number can be written over the number 1. And then you can get a common denominator. So we need this to be an x plus 4 to the top and bottom. X plus 4 to the top and bottom. Ooh. Because it's an equal sign, we can eliminate the denominator. Eliminate the bottom. We can eliminate the bottom. Eliminate the denominator because it says solving rationals. So now that we have a common denominator, make sure that we don't get a negative 4 for a solution though, because that's our restriction. So watch out, watch out. There we go. So then we can eliminate the bottom and solve for the top. Distribute, distribute. So we get x plus 4 is equal to negative 2x, negative 2 times x, and negative 8. And then we want to add, get all the x's on one side and combine those. So we get a 4x, then we minus 4 over to this side. And so, well, I went too fast. Nemo, what's going on? Stop! I don't know. I think I went too fast. Did I go too fast? I think I went too fast. Whoa! I went too fast. So let's actually add a 2x to the other side. So then we get a 3x, we get a 3x. And then we're going to minus 4 over to the other side. So we get a negative 12. And then we divide by 3, we divide by 3. Oh no, it's negative 4. Oh no! No solution. So no solution because we got the restriction as our solution. And if you plug it back in, you're going to get negative 4 plus 4, which is 0. Can't divide by 0. There we go. So find the zeros, if any, of the rational function. Find the zeros the same way you find the x-intercepts. So how do we find the zeros of the function? How do we find the zeros? So to find the zeros, you set, to find the zeros, you set y equal to 0. And solve for x. And solve for x. So this is actually y, and we're going to set y equal to 0. We're going to set y equal to 0. So we have 0 is equal to x squared minus 4. The tricky part is you're trying to solve for x. And when you have x in the bottom, you have to multiply it out of the bottom to the other side so you can solve for x. And when we do that, every single time you try to find the x-intercepts, you're going to multiply it over to the other side. And every single time you multiply the bottom to the other side, it's just going to go away. It's going to become a 0. So now we have x squared minus 4, which we can factor into x and 2 and 2. And plus and minus. Set each of those equal to 0. Set them equal to 0. So we have 2 x-intercepts at negative 2 and positive 2. Because you minus 2 to the other side and you add 2 to the other side. Wayo! Okay, so now we're ready for graphing. You got this. Try it on your own. Pause me. Try it on your own. Do you know how to graph? Well, this one, they give you the domain, negative 3 and positive 3, which is our vertical asymptotes. So they're both odd, so opposite directions. So we have a negative 3 is where one of our vertical asymptotes is. And we have a positive 3. Pause me. Pause me. Try it on your own. Pause me. Try it on your own. Try it on your own. So what do you think there? Let's take a look. So we have a y-intercept. We have a y-intercept at 0, 4. That's way up here. We also have x-intercepts at negative 6, 0 and positive 6, 0. Right? Right? They're both odd. They're both odd. Okay, so then horizontal asymptote at y equals 1. So y equals 1, well that's the y equals 1 line, which is right here. At 1. That's the y equals 1 line for the horizontal asymptotes. Good. Okay, so we graph that as well. Indicate all asymptotes with dashed lines. Always let the x-intercepts and asymptotes be your guide. Dun-dun-dun-dun. Jiminy Cricket, Pinocchio. Always let them be your guide, okay? Always let them be your guide. So because we have a horizontal asymptote at negative 6, we're going to go ahead and cross through that x-intercept and go down and let the asymptotes guide us. Let them guide us, right? They're barriers. Let them guide us. And then this is going to be odd, which means opposite directions. Opposite direction. And so opposite direction, odd. So that means we're going to come up here. We're going to come down like this. Whoa. We're going to go through the y-intercept at 0, 4. Through the y-intercept like that. Good. Good. So there's that. Then it's going to be opposite direction again. So it's going to come down beneath. You come down beneath like this. If it lets me. There you go. And then go through the x-intercept like that. right? Just like that. And so if you want to double check your graph there, if it lets me, I'm just trying to draw a red line. What are you doing, brother? There we go. Okay, good. So there's our graph, but you can double check it if you want to, double check it there. So you can go to the calculator. And so you can type that in. Make sure to use lots of parentheses, okay? Lots of parentheses. So x squared minus 36, close parenthesis, divided by x squared minus 9. And then graph it. Zoom out, zoom 9, zoom 6. Well, there's our graph. With a vertical asymptote at -3 and +3, good. And a y-intercept at 0, 4. We did it right. Woo, we did it right. Thanks for watching. See if we have time for one more. Yeah, we got time for one more. Okay, so now try number 12 on your own. Try number 12 on your own while we look at 13. Try 13 on your own. Remember, you're not going to get this for the test unless you try it on your own first. Pause me. I'm waiting. The train's waiting for you to pause me. Make sure you pause me. Try it on your own. Okay, so this factors into x and x. Factors of 4 are 2 and 2, plus and minus, right? Plus and minus. So our restrictions, our domain restrictions are -2 and a +2. Really, you're supposed to put the domain, which is -infinity to -2, and union with -2 to 2, and then 2 to infinity. But this year, they want you to list it like that. Easy, easy for you, yay. And then we have vertical asymptotes. Add -2 and +2. Wait, did something cancel on the top and bottom? That's the whole instead of a vertical asymptote. Does it cancel? No, because x squared is in the top. So x squared is in the top, x times x. So nothing cancels. And since nothing cancels in the top and the bottom, that means we don't have any holes, right? Yeah, no holes. We have no holes going on there. We have no holes. So holes, we're going to put none. Now to find the x-intercept, you just set the top equal to 0. Really? You just set the top equal to 0. So we have x squared is equal to 0. We square root both sides. And we get 0. Now the y-intercept, you also know the y-intercept, you set the x equal to 0. So the y-intercept, you set x equal to 0. And so when we do that, we get y equals 0 squared. I'm just putting a 0 there and there. So 0 squared over 0 squared minus 4. And so that's just 0 over -4, which is just 0. So we have an x-intercept and a y-intercept at 0, 0. Boom, boom. Okay, end behavior time, end behavior time. So the end behavior, if things cancel in the top and the bottom and there's nothing left, just a line or something, you would put the end behavior, or if it's slanted, you put the end behavior. Otherwise, you're going to put the horizontal asymptote. So horizontal asymptote is what we're going to ask for here. And the horizontal asymptote is depends on the powers. And so I think my powers are the same. Are my powers the same? Yes, they are. So we look at the original. We got x squared over x squared minus 4. And so the powers are the same. And since the powers are the same, you just use the numbers in front. They're invisible, 1 and 1. So use the powers in front. So invisible 1 and invisible 1. 1 and 1. So the horizontal asymptote is going to be y equals 1 over 1, which is just 1. And so let's go to graph that horizontal asymptote at y equals 1. And then we're going to graph the vertical asymptote at -2 and at +2. Okay, so this is going to be tricky. So we have to look at the end behavior, kind of weird, even or odd. And since these are both odd, it's going to be opposite. Opposite direction. Opposite direction. Well, first you use the y-intercept to help be your guide and the x-intercept. So we're going to go along the asymptote. I'm going to hit and touch that x-intercept, y-intercept. And then, since it's opposite direction is going to come from the top then. And come down, opposite direction. Right? Because those are opposite directions. Add 2 as well as -2. Opposite directions. So that's going to come down as well like that. There we go. Woo! Wow, we did it. And we found there's no holes. And we did our graph. So that was amazing. Good job, you guys. So stay tuned and watch my next video. Try them on your own first. And then push play and fast forward to see how you did. Thanks for watching. Have a jolly, jolly, la, la. La, 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 la. 12 days this year. 12 days of Christmas. 12 days of holiday. Have the first day, 12, 5 golden rings. Whoa. So it's coming up fast. And thanks for watching. And see you in the next video.